The first question of homework 5 is very similar to one of the problems that were given in the last assignment. So the first problem is, so we're given two random variables, x and y, they're independent, and we're given their density functions respectively, and z equals x plus y. And we need to find the density function of z. And firstly, we're asked to use the convolution method, which is also to say to use Laplace transform. And here we can just we can convert this density function to the using the transform to get this result. And so here we convolve the two density functions of x and y, and we have z, and we multiply the two transform that we have here, and finally we have this result. And using the inverse Laplace transform, we can get this final result. This is the analytical form of density function of z. And so very similarly from last question's method, we have this triangle here. Yeah, because z minus 1 times this step function is this, and then z minus 2 is this, z minus 3 is this. And using a very simple, we can just draw the graph, and eventually we have this triangle here. And yeah, so that's so much for the first method. And secondly, we're asked to use the geometric method to solve this problem. And this method is much more straightforward. So basically, we just actually multiply the two density functions. It's not that hard. And in the clue, in the document that we're given, it says that we can calculate the density function of z first for z equals x plus y, with density function of x being u of x minus u of x minus 1. Density function of y equals u of y minus u of y minus 1. And then shift the result to the right by 1. And so the cumulative probability of z is when z is less than this. And let's just switch let's switch z to x plus y. Here we'll have this line here that is x plus y is less than z. So in this square, this is our space. So when z is less than 1, we have this triangle here, and the area of this triangle is the cumulative probability of z. And very easily we can have z squared divided by 2. And then the derivative of that would be the density function. So here we have z. And we shift this function to the right by 1. We have z minus 1. And yeah, that's when z is from 1 to 2. And the second scenario is when z is larger than 1. So now we don't have a complete triangle anymore. We need to get rid of like the two little triangles here. So in this case, the cumulative probability would be the area of this big triangle minus the two little triangles. And we have minus z squared over 2 plus 2z minus 1. And the derivative of that would be the density function. So here we have minus z plus 2. And to shift this function to the right by 1, we have minus z plus 3. And that's when z is between 2 to 3.